Hello again, scientists. Welcome back to part 2 of our video session on acceleration. So we just finished together using our formula to solve a problem to find the acceleration of an object in motion. Specifically in this example, it was a peregrine falcon. So at this time, I would like to challenge you to try a problem on your own. So this is your time to practice applying this formula to calculate the acceleration of an object in motion. So I will go ahead and read this example once for you, and then I'll ask you to pause your video and to try it. So here is our example. A girl on a bicycle increases her velocity from 5 meters per second to 20 meters per second in 5 seconds. What is the acceleration of the bicycle? So it's asking you to consider, with the information that you are given about her velocity and time that's gone by, what is her acceleration as she increases her velocity? So go ahead and pause the video at this time. Either use some scrap paper or maybe your science notebook and see if you can calculate this girl's velocity. Alrighty, welcome back. I hope that you took a moment to pause the video and to give this example a try on your own, but we are going to run through it together at this time just to make sure you are right on track with this one. So again, we are calculating this girl's velocity, we're calculating her acceleration as we see her velocity changing over time. So we are going to be solving for acceleration, which is the change in velocity divided by the change in time. So her final velocity, as I set this up, is the velocity that was last recorded. So her most recent recording was 20 meters per second. So that is her final velocity that she reached, the last one, 20 meters per second. And I am going to be subtracting her initial velocity, the first speed she was recorded moving at. So I will subtract 5 meters per second. So I have set up my formula to find my change in velocity, and I need to also divide by my change in time. We know that we measured her velocity changes for 5 seconds. So that means at the end of our time, there were 5 seconds that had gone by. And before we started measuring her change in velocity, there was no time that had gone by. So we'll say 0 seconds. So that means I've set up my formula to find this change in velocity and divide it by the change in time. 20 meters per second minus 5 meters per second is going to give me a total of 15 meters per second. So that was her change in velocity as she moved along her path on her bike. And we are going to divide that by the change in time. 5 seconds minus 0 seconds means there was a change in time of 5 seconds. So now that we have carefully done our calculations to find our change in velocity and our change in time, we can take our final step and divide these pieces of information along with our units. So 15 divided by 5 is going to give you a total of 3. And we need to include our correct units for acceleration. And we have meters per second divided by seconds. And as you know, when we rewrite this correctly, our final value for this girl's acceleration on her bike is going to be 3 meters per second squared. And we see meters per second squared because there are 2 values of time, 2 seconds in our denominator. So this girl's acceleration is going to be 3 meters per second squared. There's one more example. So I hope that you are able to find her acceleration successfully. If not, keep practicing and you'll get a chance to do so in the OMS. So as you can imagine, not everything in the world is constantly increasing their velocity. Sometimes things have to come to a stop. So that means we can calculate something called deceleration. So if acceleration is changing your velocity in a positive way over time, if you're increasing velocity, then deceleration is the opposite. It means reducing your velocity over time. So here would be an example of something decelerating. Our example says, a train traveling at 40 meters per second screeches to a stop in front of the station in 5 seconds. What was the train's acceleration? So we are using our formula to find acceleration, and we know that because we are reading carefully that our last sentence in the problem asked us to find the train's acceleration. So that means we are going to set up with our acceleration formula we have here. I'm finding acceleration, so I'm going to leave this as A. I'm going to go ahead and move that down so it lines up a little bit more. There we go. That's more helpful. And we can use our acceleration formula once more to find the acceleration of the train. So here is where our situation is different. We know that our train is traveling to the station at 40 meters per second and screeches to a stop. So that means its final velocity when we stop recording it is going to be 0 meters per second. If something is stopped, it's not moving any distance. So that means its velocity would be 0 meters per second. So its final velocity once it stops at the station is 0 meters per second, final velocity. And we are going to subtract its initial velocity that it was traveling when it started of 40 meters per second. So you might be looking ahead a little bit and considering what might be different about our value for acceleration in this situation. We shall see. So now that we have set ourselves up to find the difference of velocity, we need to do the same thing for time. We know that 5 seconds had gone by from when we started measuring that train's velocity to when it stopped. So that means its final time when it stopped was 5 seconds. And we hadn't started measuring time that passed before it came into that station. So that means there was no time that had elapsed. There's no time that had gone by. So we are going to say 0 seconds. So we have found our change in velocity and our change in time. So let's calculate those values. 0 minus 40 is going to give us a value of negative 40 meters per second. So I want us to be really careful and intentional in this situation to realize that we are taking 0 and subtracting another number. 0 minus a positive number is going to give you a negative value. So we have negative 40 meters per second divided by the change in time of 5 seconds. 5 minus 0 gives you 5 seconds. So we've calculated our change in velocity, our change in time. So we have one step left, and that is to divide in order to find acceleration. A negative number divided by a positive number is going to give you a negative. Negative 40 divided by 5 specifically is going to give you a negative 8. And again, as a scientist, please use your tools that you have available. If you want to use a calculator to be more accurate, go ahead and do so. I encourage it. And you will use a calculator and be able to see that negative 40 divided by 5 is indeed negative 8. And we also need to include our units, negative 8 meters per second per second. And I think by this point, you can remember when we see an answer in meters per second, we call it meters per second squared. And our value for acceleration was negative 8. So remember, the difference in this situation was that the train was coming to a stop. So that means if an object is traveling at a velocity that is positive and comes to a stop, it is going to have a negative value of acceleration. It is going to decelerate. Decelerate. So if something has negative acceleration, we call it deceleration. So the train in this example would be decelerating as it approaches the station and comes to a stop. Negative values of acceleration tell us that objects decelerate as they move. So we can also use information from tables and graphs in order to help us calculate changes in velocity and time in order to get an object's acceleration. So let's use our information here and compare it with our graph to find a change in acceleration. You are measuring the acceleration of your friend's new speedboat. You start your timer when he passes by you, and then stop the timer 5 seconds later. Use the graph to find his average acceleration. So in this story, we are given information about time 5 seconds later. However, we need to use our other piece of information, this graph, in order to tell us about velocity. So we are told that this is a time versus velocity graph, and I can see that by looking at the labels on the x's. So when I see time, I can see it's divided by seconds. 1 second passes by, 2 seconds passes by, 3 seconds pass by, and we have all the way up until 5 seconds when we stop the timer. So that means we are able to use this system and look at each second of time that had passed by and find out at what velocity the boat was traveling for each second of time that has passed. So our job is to use the final velocity, which is after 5 seconds of time. So I'm going to mark this VF, final velocity, is at the end of when you timed him, 5 seconds later. I find my 5 and I travel right up. And to subtract the initial velocity, which would be at time 0, because I haven't started timing yet. Initial velocity. So that means in order to set this up, I need to read my graph in order to find the velocity at which they were traveling for each amount of time. So acceleration is going to equal my final velocity. And when I look on my graph, final velocity is 25 meters per second. Velocity is marked here on the y-axis. So when I find my line at 5 seconds, I can track it over to 25 meters per second. And I'm going to subtract my initial velocity. My initial velocity is 5 meters per second. Because I find my time 0, my initial velocity, and I can see the line is at 5 meters per second. So I've found the change in velocity, and I'm going to divide that by the change of time. We know that 5 seconds went by, so that means I'm going to take my final time of 5 seconds and subtract it from my initial time when I started at 0 seconds. And now I'm able to divide this difference in velocity and in time. 25 minus 5 is going to give me a total of 20 meters per second. We're running out of space here. Holy guacamole. Okay, and we are going to divide that change in velocity by the change in time. 5 seconds minus 0 seconds is going to give me a time of 5 seconds. So that means altogether, I can use this information, move on down, and see that 20 divided by 5 will give me a value of 4. And I need to include my units, meters per second, which gives me meters per second squared. So we are able to calculate the velocity changes, the time changes in order to find the acceleration